Unit 2, Data and Analysis. Chapter 4, Storing Information. The Information Age. Our world has moved to the Stone Age, the Dark Age, and the Industrial Age. Many say that right now we are living in the Information Age. That's because we have shifted from a focus on making stuff with our hands to using information technology to create. We have found new ways to use information to help us create. Computers are information processors. This means they take information and make it easier for us to use. For example, map apps process information from satellites to help us find the quickest route to our destination and even avoid traffic. Social media apps such as Snapchat, Twitter, Instagram, or Facebook process our personal information, likes, posts, etc., and create profiles of who we are that businesses can use to try to sell us stuff. To note, you don't pay anything to use social networks, but that doesn't mean they are free. The cost of using them is that you hand over tons of information about yourself. That's why it's always important to get guardian's permission and guidance before giving out any personal information online. Self-driving cars gather and analyze large amounts of information to make predictions and decisions. Radar, which stands for radio detection and ranging, using radio frequency to detect the presence of or distance from an object. LiDAR, which stands for light detection and ranging, using laser light to measure the distance to a target. Ultrasonic sound waves and video recordings from cars' external cameras and sensors are collected, temporarily stored on the car's hard drives, then sent over the internet to powerful computers that analyze the data using artificial intelligence AI programs. The AI programs piece the data together to learn how to drive by analyzing how humans drive safely. The more information we have and the better tools we have to understand the information, the better decisions we can make. For example, when you try to buy a birthday present for your friend, it is much easier to do than trying to buy a present for a new kid that just moved into town. This is because you have more information about your friend, so you are able to make a better decision about what they would like. Computers use data. Data is a collection of unorganized figures, words, and numbers that have not yet been given meaning. Data has many different forms depending on what kind of information it presents. Information is data that has been organized to have meaning. A context is given to the data. For example, all the answers to a survey are data, and the average of the results is information. Input data is the unorganized information entered into a computer. Output data is the information after the computer has processed it. Input data, the computer processes output data. In a video game, pressing keys or buttons on a game console processes the character moving around the screen. In social media, typing comments or uploading photos and videos processes edited videos and photos along with your profile. On a microwave oven, selecting numbers or buttons on the keypad processes the food cooking in the oven for a given amount of time. In a graphing program, entering numbers for different categories processes a graph of the numbers. Computers take input data like answers to questions, numbers, and uploaded images and turn the data into a format they can understand and process. For example, pictures are broken up into millions of tiny chunks by a computer, and then the color of each chunk is recorded in a long sequence of code. The computer then processes the code and sends it back to the user as output data. To show the picture, The computer reads the long sequence of code and reconstructs the image on your screen by displaying the corresponding color in each tiny chunk, kind of like a super detailed paint by number. Code is a system of symbols, letters, and numbers used to represent something else. Encoding data. Data has to be written in a format the computer will understand. This means you have to encode the data so that the computer can process it. When you encode information, you change an image, video, words, etc. into code. For example, Morse code operators in World War II would encode written messages into dashes and dots that were sent over telegraph wires. And telegraph wires are an outdated communication system that use electric signals. When you decode information, you convert code into a understandable form of communication. For example, when the Morse code operators would receive coded messages in the form of dots and dashes, they would decode the dots and dashes back into English. There are several data encoding schemes we can use to help a computer understand input data. Data encoding schemes are ways that we can represent all types of information so that computers can understand it. Computers only understand sequences of the digits 1 and 0. Any code that uses ones and zeros is referred to as a binary code. This will be discussed in detail later. Encoding schemes were created to help computers understand, interpret, and create data by reducing all data, images, sounds, videos, numbers, colors, symbols, and other types of information to ones and zeros. You could imitate the way computers store an image by making lists of ones and zeros, where 0 is a white box on the grid and 1 is a green box. Here's how the data will be represented to draw a simple giraffe on 5x5 grid. Encoding colors. Different types of data like colors, numbers, and pictures can be encoded in different ways. The most common ways colors can be encoded are through the coding schemes RGB and hexadecimal. You can use a scanner to encode an old photograph into digital data that a computer can understand. Scanners work by using a sensor that detects colors and encodes the entire photo into a series of number values. The scanner puts all these values in an order that a computer can understand and use to recreate the image on a computer screen. RGB is color notation that uses 3 numbers separated by commas, where each number is between 0 and 255. Computers encode each value to binary numbers. Each of the 3 numbers represents a different shade of red, green, and blue. That's where the name RGB comes from. When the different shades of red, green, and blue are combined, they can make many more colors. There are 16 million ways to combine 3 numbers between 0 and 255. This means that there are 16 million colors that can be represented in the RGB encoding scheme. The hexadecimal color notation, or hex for short, uses 6 characters to represent the same 16 million colors as RGB. Hexadecimal is different from RGB because it uses numbers and letters. It uses combinations of the numbers 0 to 9 and letters A to F. For example, sharp FF00B4 would make a pink color by using the letters F and B as well as the numbers 0 and 4. Each set of 2 characters, such as FF00 and B4, represents a different color. The first 2 characters represents red, the next 2 green, and the final 2 blue. And just like with RGB, the different number and letter combinations represent different shades of each individual color. The computer language CSS uses this symbol to represent hexadecimal colors. Although data such as colors can be represented in different ways, the important part is that each color uses an encoding scheme so that computers can understand the information. Representing colors. In the table below, the first two columns are schemes, ways that computers read colors. Each encoding scheme is translated into binary code. The other three columns are examples of how humans read or identify colors. Encoding colors into numbers and letters is just one way information is made readable by computers. Sounds, keyboard inputs, touchscreen taps, thumbprint readings, GPS locations, and all sorts of data are collected and encoded into a format that computers can understand.